Here is an interesting question. We need to find area between tangent and the coordinate axis. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a very interesting question based on tangents on a curve. In a test paper for calculus, these type of questions are normally seen and they are pretty difficult at times. We'll try to understand the concept of answering such questions in this particular video. Tangent to graph of function intersecting the coordinate axis. The tangents to the curve f of x equals to 8 over x squared at x equals to a intersects the coordinate axis at A and B. Find the area of triangle AOB where O is the origin. You can always pause the video, answer the question, and then look into my suggestions. In case you want to learn from me, you can send an email on the address given. All our students are doing extremely well. Some of them are right there on the top of the class, getting awards and scholarships like Akshit.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now let us see how do we solve such a question. Well, the idea is first to visualize what we are getting into. We have a function 8 over x squared. We need to find the area of a triangle formed by the tangent and the coordinate axis. Let's try to sketch it. The function f of x is equal to 8 over x squared. Now, how do we sketch this particular function? Let's try to understand that part also, as it may be useful for many students. We notice that it is always positive, right? X squared will be positive always. We'll begin with the graph of x squared. So parabola is kind of like this, right? So this is the graph of x squared. Now when we do reciprocal of this, that is 1 over x squared, then we'll have a vertical asymptote at 0, right? And the other two parts will be like 1 over x graph, which will be kind of like this. Make sense? So this graph which I have drawn is of 1 over x squared, reciprocal. But the function is 8 over x squared, so we'll multiply by 8. So the points which we see here, which is going to be at 1, will now be at 8, so vertically stretched. So let me just draw the stretched function, vertically stretched function. So it may look like something like this. Make sense? So the points here are pushed up 8 times. So this point here is pushed up 8 times. Perfect. So you have a graph as shown there in red, which is our function. Let me write down here f of x. So we have the function and we are looking for a tangent to this particular graph at any particular point. So now let us sketch the tangent also at some point. So, okay, so let's say this is the tangent, which intersects coordinate axis at A and B. So let's say this point here is A and the other point here is B. So that is forming a triangle with the origin O. And what we need to find is area of triangle AOB. Makes sense? So we are looking for the area of this particular triangle. So I hope you have understood the whole question. Perfect. At this stage, you can definitely pause the video and then answer. Okay, let's see how do we find the points A and B. So first step is, let's find the derivative of the function. So derivative of this function will be what? Some students prefer to write the function as 8x to the power of minus 2. And then it's easier for them, right? Minus 2 times 8 gives me minus 16. And x to the power of minus 3 means x cubed. So we have the derivative of the function. At any point, let's consider this point to be A. In that case, the y value will be 8 over A square, correct? So a point whose x value is A, if x equals to A, then y will be 8 over A square, right? Is that part clear to you? So the derivative of this particular function at A will be minus 16 over A cubed. Perfect. So this is at a point P, which is A, and the y value being 8 over A square. So we are looking into the right half. A could be a negative value also. Perfect. So definitely in this function, we know x is not equal to 0, but it could be any other value. So that becomes the slope of the tangent at a given point. And now what you should do is find the equation of line, correct? So minus 16 over A cubed is the slope of tangent. So let's find the equation of tangent line. So here is a neat graph for you. So we are looking at this particular point here, which is the values A, and the y value will be 8 over A square. Clear? And we are going to find the 2 points A and B generally, and then the area of the triangle formed with the origin and the tangent. So once again, we have the function f of x, which is 8 over x squared, whose derivative at A is minus 16 A cubed. So what is going to be the equation of tangent line? Well, we can use the equation point slope form, right? That is best to use in such cases. Which is y minus y1 equals to m times x minus x1, correct? So y minus y value for us is, let me write down the point, which is a over x squared, correct? So y minus a over x squared, a squared, sorry, 8 over a square, sorry, 8 over a square. So y minus the y value, which is 8 over a square, equals to the slope, which is minus 16 over a cubed times x minus a. Perfect. So we get the equation of tangent line in slope intercept form, right? So this is the equation of tangent line. Perfect. So once you have the equation, we need to now find the x-intercept and the y-intercept. Right? So now, I'd like you to find x-intercept and y-intercept. So x-intercept is a point where y is equal to 0 and y-intercept is where x equals to 0. Substitute the value here and then find points A and B, correct? Perfect. So let's simplify this equation. Let me write this as one equation of tangent line, right? So let's find the intercepts. So we have y minus 8 over y1, which is a square, which is minus 16 over a cube, the gradient, the slope at this particular point, which is a, and 8 over a square, correct? The x value is a, so minus a. So let's begin with x-intercept. So x-intercept means y equals to 0. So I'm going to equate y as 0 here. So we get 0 minus 8 over a square equals to minus 16 over a cube times x minus a. So x minus a will just cross multiply, minus minus change, right? So we have 8 over a square times a cube over 16 equals to x minus a, correct? So we could simplify this part. Goes 2 times a by 2, right? So that gives you the value of x as equal to a by 2 plus a, which is 3 by 2a, correct? So we get this particular point, which is generally 3 by 2a in terms of a. Perfect. So we got the x-intercept, which is a by 2a. And now let us find the y-intercept. So we get 3 by 2a as the x-intercept when the tangent was at a, 8 over a square. We are working on the line y minus the y value, which is 8 over a square, and the gradient minus 16 over a cube times x minus a. So let's find the y-intercept now. So y-intercept is when x equals to 0. So let's find the y value, which is y, and we have minus 8 over a square on this side. We have minus 16 over a cube. Substituting 0 for x, we get minus a here. Perfect. So that means it is y equals to. We can take it to the right hand side. 16 gets multiplied with minus a, so we get plus 16, right? So we have 16 over a square plus 8 over a square, which is 24 over a square, correct? So we have the y-intercept, which is 24 over a square. So we have both x and y intercepts. Now we need to find the area of triangle. So let's calculate the area of triangle now. So what is the area of triangle? It is half base times height. So half of base, which is x-intercept 3 by 2a, times the height, which is 24 by a square. Make sense? So we can simplify this. 2 times 2 is 4, which goes 6 times, and 3 is 18 over a. You get the idea. So the general expression for area of this particular triangle is going to be 18 over a. Perfect. So for different values of a, if you make a tangent line going like this, we get different values of the area. And you can substitute and get the answer, right? Now, this question could be extended. So let me just extend this question. To consider a case, what happens when A approaches negative infinity? Means we're looking for a point A far away on the positive side. In that case, what happens? Also, here is a note for you. Since area is always positive and A could be on this side also, right? So we should take absolute value of A. Okay? So we'll say area of this triangle is equal to 18 over absolute value of A. Make sense? Perfect. So we have extended this question as A approaches infinity. What happens? Well, A approaches infinity. Area is decreasing, you see. The area decreases. We can say that the area of the triangle actually approaches 0. Because dividing by a very large number will result into something 0, right? So that is another important conclusion in this particular case. Perfect. So the area approaches 0 when the point A is far on the right hand side, or even when it is approaching negative infinity, right? It approaches 0. Make sense? So that is how we are going to solve such a question. So I hope you understand and appreciate how the solution has been derived, each and every step of this particular question. Each and every step of this particular question is of importance. We have developed a strategy to answer such a question, sketching a graph, and then understanding the question and finding the solution is key for success. I hope you understand and appreciate it. Feel free to write your comments and suggestions. In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.